Hello students, in this video I will give you the theory behind the Francis turbine because you have a lab in your paper that to conduct the performance characteristics of Francis turbine. So we have already discussed what is Pelton turbine, that's Pelton turbine, Francis turbine, and there is another more turbine is Kaplan turbine. So all are hydroelectric turbine. But among them, the Francis turbine is most widely used because it has a high range of, it can work in high range of head as well as and high range of flow as well as the high range of velocity. So it's a basically Francis turbine is a reaction turbine, unlike the Pelton turbine, which is a impulse turbine. So impulse turbine means there is a whatever the energy is available at the inlet of the turbine is the kinetic energy, and wherever the reaction turbine, the energy available at the inlet of the turbine is both kinetic energy as well as pressure energy. So while striking the energy that carried by the water or the flow is carrying both pressure energy and kinetic energy, and that is going to be converted into mechanical energy through this turbine while rotating this wheel or rotating this tunnel, the blades of the tunnel. So we'll go to the theory part. So and why it is, and it is reaction turbine, the Francis turbine is also called as a mixed flow kind of turbine, because you have seen here the fluid is enter radially inward direction and it moves out through axial direction. So it's move out with this is the axis of the runner, so move out in an axial direction, but it's enter through the radial direction. So it is radially inward and axially outward flow reaction turbine. So if you can see here, so Francis is a reaction turbine in which the fluid changes pressure, it moves through the turbine and keeping up its energy. And the turbine is located between the high pressure water source and a low pressure water exit, because whatever the pressure is available at the inlet of the turbine is high pressure, and whatever is the pressure at the outlet of the turbine is almost equal. So that's why we have used this draft tube also. So draft tube is what is doing is that it's gradually increasing increasing the pressure, because whatever the pressure is available at the outlet of this turbine at this position is the equal. So we have to disperse that pressure, so and to make it to the equivalent to the comparable to the atmospheric pressure. So we have used this draft tube, which gradually increases the pressure and disperse the water at the atmospheric pressure condition. So the inlet turbine is a spiral shape. So you can see here is a spiral shape. Then the guide fans direct the water transiently to the turbine wheel, which is known as a runner. This radial flow water acts as a runner fans and causing the runner to spin. This is the radial flow direction. At the inlet, the guide fans may be adjustable to allow efficient turbine operation for a range of water flow conditions. So we can see there is a guide fan, so it can be rotated in a direction to make a suitable flow of water while striking this runner blades. So at the point of exit, the water leaves with no frill and very little kinetic and potential energy, because all of the kinetic energy or most of the kinetic energy has been converted to run this runner blades, and that is actually turns the shaft which is connected to the generator, and it's produce electricity out of it. The shape of the turbine axis tube helps to re-accelerate the flow of water and recover the pressure. As I mentioned, so this is draft tube is used to recover the pressure up to the atmospheric pressure. So if you can see, this is the main parts. This is the main parts. One is the spiral casing. So this is the casing, which it's putting completely enclosed and airtight spiral casing. You have to put it. The casing of runner always full of water from the penstocks enter the casing, in which area of cross section of the casing goes on a decreasing gradually. Since the casing is spiral shape, water enters in a runner at a constant velocity throughout the circumference of the runner. Then we have the guide fans. The guide fans allow the water to strike the fans fixed on the runner without any shake at the inlet. Also, by a suitable arrangement, the width between the adjacent fans of the guide mechanism can be adjusted so that the amount of water striking the runner can be varied. Then we have, this is the most important parts of the Francis turbine, that is the runner. So it is a circular wheel on which a series of radial curved fans, or you can call it blades, are fixed, and surface of the fans is made very smooth. The radial curved fans are also so shaped that the water enters and leaves the runner without shock. The runners are made of cast steel, cast iron, stainless steel. The runners is connected to the shaft, which is that connect the generator shaft. Then we have the draft tube. This is another important part because otherwise whatever the pressure is available at the outlet of the turbine is the vacuum. So we have to disperse the water at the atmospheric condition. That's why this draft tube is used, which is gradually increasing the area. So discharging water from the turbine to the tail race. So tail race, you can have it as a, in our lab it will be a sump or whatever. The pressure at the exit of the runner is generally less than the atmospheric pressure, hence the water is discharged at the tail race through the draft tube. So these are the equations that are involved. I don't have to go through that. So if you have the comparison, so there is another turbine, is a Kaplan turbine and Francis turbine. Both are reaction turbine. Like the Pelton turbine, that is an impulse turbine. But you can see the range that Francis turbine can operate. It's a very very high range of it can work on. Like it's working from 30 meter to 550 meter. This is a pressure head that it can work on. It is working. That's why the Francis turbine is mostly widely used in all the hydroelectric pumps, hydroelectric hydroelectric power generation. This is used, and then this number of fans that is used is 15 to 25, and specific speed that is it can work upon. So it's also having a very high range. So however, some things are that it requires large area, and speed runner you can see it's also very much higher. And flow is, it is important, but why it is called a mixed flow reaction turbine? It is Francis turbine. Remember, the Francis turbine is a mixed flow reaction turbine because its water is entered radially and it exists axially. However, the Kaplan turbine is completely axial turbine. So we have the cavitation problem because of the pressure reducing very drastically. That's why the cavitation occur. Then we have these performance characteristics of Francis turbine that we have to determine in the lab classes. So this is one is constant head characteristics. In order to obtain this curve, the test are performed on the turbine by maintaining a constant head. So we have to fix the pressure head and constant gate opening and speed. So we have to, we have same kind of speed, constant gate opening, and the speed is raised by changing the load on the turbine. So we have to, how is speed? We have changed the speed by putting the load on the turbine, and so by doing that we can have different kind of graphs we can obtain. For one graph is obtained for discharge rate, then another for is the power output, then another is the overall efficiency. So this is the constant head characteristic because it is, we have put the head, pressure head make constant, and whatever the curve we have obtained by raising the speed by putting some load on the turbine. Then we have constant speed characteristics. So in order to obtain these curves, the tests are performed the turbine by operating them at constant speed. So like this, we have this kind of curves we can obtain while doing the experiment. You can have it. So, but in our lab we have only for demonstration purpose. Then we have this constant efficiency curve. These are also shows the efficiency of turbine for all conditions of running, and hence they are also known as a universal characteristic curves. So this is the theory behind your lab experiments of Francis turbine. Hope you have got it. Thank you.